the simulations that you've done with the theory. So what this solid curve is, kind of like a curve that you would see from calc class. Do you see it?
Yeah.
That solid curve? That's the theoretical distribution, the bell-shaped curve. With if it was it's the Halloween candy case. So if it was due to random chance, it would look exactly like flipping a coin 10 times over and over and over again, and then looking at what happens. That's what you guys did in class. And so here what it's showing you is theoretically what that will look like. It's generated from a formula. And on top of that, you see these dot plots that they've done. That's the simulation that we did in R. So they just ran that simulation in R. I had you guys do that in class the other day with R. And so they're showing you that overlaying one on top of the other shows you that they're matching up. And if they overlaid it 1,000 times, they had 1,000 simulations, that's a ton of dots. So they look almost perfectly matched. That's the central limit theorem, right there. They've shown it to you with data, that those two match if I had enough of a sample size. And that's pretty cool. So in the simulated data, that's the dots, I can calculate what % of the data ended up in these two things. The null hypothesis was that it's due to random chance, so the probability that a child would choose candy would be what? 50% or a half. If they don't choose candy, it's not a half. So it's not one-sided, it's two-sided, because it's not, being not means it's on the two ends. It could be over on the top or over on the bottom. And then they looked in the sample and they said, well, in my sample I got, this was the proportion of heads that were above this area, and this was the proportion below. And so I can just count the amount of data points that ended up here and here. Do you remember that day in 104? It was leap year, but do you remember that day in 104 where they talked about Riemann sums?
Yes.
And they broke up things into rectangles? Your data pipes are your rectangles. So if you have a theoretical curve, you would calculate the integral to get the area under the curve.
And that would be the p-value?
That would be the p-value, exactly.
Central limit theorem?
The central limit theorem says that if you have enough of these simulations, the theoretical curve and the lineup are going to match up. So they've done that for you.
So because this is a two-sided instead of one-sided, do we add the orange
Yes.
to the p-value?
Yes. You add those two areas. So when I first started doing statistics, which, believe it or not, I've never taken a stat class. They're doing a wonderful thing for you, having you take a stat class, because it's hard to learn things when you get old. But I started learning stats to do work in the area of fitness, and there's a lot of data that comes at me. And I remember a graduate student in statistics working with me, and I knew by definition that these were areas of the curve. So I'd get into Mathematica and calculate the integral. And he would just look at me and say, Dr. Thomas, we have tables for that. But this is what it is, it's an integral. I can calculate the area of the curve. So for the longest time, that's what I was doing, putting it into Mathematica. Can I have you close your laptop? Close laptop?
My book's on my...
Yeah, you won't need it right now. You'll need it in a minute, probably. Okay, last thing, and then we'll run through an exercise, okay? Oh, you do need your book. 1.3. Read the book, and then answer that one question. Why are they using what we call a standardized curve?